Again, last year slot 1 question, circle of diameter 8 is inscribed in a triangle ABC where ABC is 90. If BC is equal to 10, find the area of the triangle. So again, a right triangle, a circle inside. We've seen this before, right? This will be 4, 4, 4, 4, 4, 4. It looks also 90 degrees. Yeah. If BC equal to 10, find the area of the triangle. Okay, we know this entire length, but we don't know any other length except the radius, right? So we don't know the split of this as well or anything. What is the quickest way to approach this? If we knew some of the other things, for example, for the area of the triangle, what is the first thing that should come to my mind for area of the triangle? The first thing that should come is I know the radius. If I could figure out the semi-perimeter, I'd be done. Is there a way to figure out the semi-perimeter? This is given as 4. Do I know? I know BC as a whole. Do I know any other side? Even if I use the in-center equation, the A plus, like a perpendicular plus base minus hypotenuse by 2, it would be AB plus AC minus 10 by 2. Okay, so this will just give me that, okay, AB plus AC will be equal to what, 18. But do I have another relation to calculate what AB and AC is? You don't even need that relation, although in this case, the moment you figure out that AB plus AC is equal to 18, you know BC is 10. So the semi-perimeter would be 18 plus 10, which is AB plus AC plus BC, which is 14. 18 plus 8, 28, and semi-perimeter would be 14. So area is equal to nothing but R into S. So you can have 14, 4, and 56. So that is one way to do it. Any questions on this? Again, a direct application of this, there's nothing fancy going on here. So AB plus AC minus 10 by 2, this is the in-center equation, which is P plus B minus H by 2. AB plus AC, this got me 18. I don't need to find out what AB and AC are. I just need a semi-perimeter, which means I just need perimeter. I already know one side, I know the sum of the two sides. S is 14, R into S is 14, 4, 56. What if you forget this formula there? P plus B minus H by 2. Is there another smarter way to do it? Like, you should definitely not forget this. Like, it's a pretty basic right triangle in center in radius formula, but is there another way to do it? Now that we studied circles, now why did I put this question in the question for circles and not triangles? Because there is an alternate method I wanted to show you to do this, which is, you see this point that the tangents, these lines will be tangents to this circle. Now this is 90, this is 90, this is 90, this is sort of a rectangle here. So this is 4. We know this entire piece is 10, so this is 6. This is 4, so this will be 4. Tangents from same point are equal. This is 6, this will be 6. This is x, this will be x. Like, I don't know, I cannot figure this out from the tangent relations itself. So this is x, this will be x. Just write the Pythagoras around this. X plus 6 would be equal to x plus 4 square plus 10 square. This is why I had put this question in circle, so that this approach also you know, and you can find out x and find out the semi-perimeter and the and then so on and so forth, right? Once x is there, you can easily find out this out. Here again, there's a small like thing that you can use to shorten your time. Now that I've seen the equation, we know basically that, okay, you can solve this by quadratic, it will give you the correct answer. X plus 6, x plus 4, 10 square, one variable quadratic. Easy to do, no problems at all. The smarter way to do it would have been, we know that this and this are separated by 2. Like, this is x plus 6 and this is x plus 4, so this and this are separated by 2, and this is 10 square. We know a Pythagorean triplet, which is 10, 24, and 26. Like, basically the 5, 12, 13 setup being promoted, like being multiplied by 2 throughout. So I know that 10, 24, 26 makes a Pythagorean triplet, right? So x plus 4 will directly be 24, x plus 6 will be 26, and you can figure that out from like there on. So you don't need to even solve the quadratics for that matter. Just a sec, actually this is incorrect, because the hypotenuse is not 10, right? The hypotenuse would have been this. So they put P plus B minus S, so hypotenuse is not 10 here. So yeah, so please ignore this. This is not correct actually, just realized. But is this method clear? That same points tangents equal can be used. So basically, if we write x plus 4 will be equal to 24, and this just like struck me because the equation was in front. So 10, 24, 26 can be used. So x will be equal to 20. So basically, this is 20. This is 20. So what will be the perimeter? 20 plus 4 plus 24, 28, 34, 40, 60. So f will be 30, and r we know is 4. Area is 120. This is not correct. Okay, so you can do it this way as well. That is what, and that is the previous year question only. So just using on the fact that tangents from the external point are equal. Any questions on this? It's got duplicated here. So okay, a question on cyclic quadrilaterals now. So ABCD is a cyclic quadrilateral with AB equal to 11 and CD equal to 19. P and Q are points on AB and CD respectively such that they are side lengths. Determine length of line segment form. Okay, so let's just start drawing this as we read on, right? So AB equal to 11, CD is longer, so let's just make it something like this. A, B, C, D. P and Q points such that AP is equal to 6. Okay. DQ equal to 7, so it will be slightly further here. So this thing. And PQ, okay, PQ that given 27. This is 6. This is 7. AB is 11, so this would be 5. CD is also 19, so this is 7, so this will be 12. So basically I know these sides then. I don't know the opposite side, but I know these sides. Such that AP equal to, am I missing out on some data? No. So everything has been recorded in the figure now. Okay, it says that determine the length of line segment formed when PQ is extended on both sides until it reaches the circle. Okay, so let's extend PQ on both sides until it reaches the circle. So if this is, let's say, MN, they want us to find the length of MN. Okay, so this is the setup. Now, what is the first thing, like in the last question, the first thing was like, okay, right angle, circle, some things some dots start to connect, right? What is the first thing that is very, very visible here? I can clearly see that these are intersecting seconds or intersecting basically line segments inside, right? So like this intersects this intersects this. So I can apply the second rule here. That should be the first thing. And in that also I know this length. So if I take PM is equal to, so I need to find MP and QN basically, right? So if let's say MP is equal to X, this is equal to X, for example. So I can write by the second rule that AP into BP will be equal to MP into PN. AP into BP, I know 6 into 5, 30. So if this is X and this is, let's say, Y, so I can write MP as X. PN I can write as this, like this is PN. So PN I can write as 27 plus Y. So this is 1. Similarly, I can apply it here also. And again, the hint came from when I saw that seconds are intersecting. And as we had mentioned there also, right, that second tangent theorems and second theorems are easier to identify in a problem because like you'll just see them intersecting that way. So for this one, it will be 12 into 7 equal to MQ into QN. MQ is nothing but X plus 27. QN is nothing but Y. So this will be 84. So the two equations that I have is X into Y plus 27 equal to 30 and X plus 27 into Y equal to 84. Now, do I need to really solve these two to figure out the length? I could do that and it would give me, like it would be a totally correct approach. But it should strike me that if the product of two numbers is 30 and one number is already greater than 27, it is 27 plus Y, right? So what is the only possibility? Y would be equal to 3. You need to find a figure factor of 30 that is more than 27. So this number would be 30 then. So Y equal to 3, X equal to 1. Let's just check if it fits in the other equation as well. If you put Y equal to 3 here, so and X equal to 1, so this will be 28 into 3, which is 84, so it matches. So this is then correct. So X equal to 1 and Y equal to 3. So the entire length of MN which we need to find out is nothing but 27 plus 1 plus 3, which is 31 units. And that's done. So good application of the second rule. Cool. Moving on to the next. In the given figure, CD is perpendicular to chord AB. Okay, so basically this angle is 90 degrees. If CD equal to 6, AC equal to 4, BC equal to 17, find the radius of the circle. Now, clearly from the figure itself, again, this is one question that can be figured out from the figure itself, that find the radius of the circle, right? So intuitively, the first thing to do would be to like complete this. Right. Now, I don't know that if AB is the diameter. It is nowhere given that. So it may be that the center lies somewhere here, right? And then you have to draw like radius and all, etc. But if I know, like if I have just completed this triangle, what do I see here? What is this figure? A triangle and a circle outside of it. Where is the circumcircle? No? This is just the circumcircle. So if I can find the circumradius of this triangle, the question is done. For circumradius, I only have one formula, so that makes it even easier because I only know one formula, so that is the only one that should be used here. What is the circumradius formula? ABC upon 4 into area. Do I know these things? I don't know all of them because I don't know these sides, but I can figure out these sides. This is from Pythagoras theorem. So this is basically root 6 square plus 17 square. It's root 289 plus 36. So would be root 325 probably. I can figure this out AD as well. So this would be root 6 square plus 4 square, so root 52. This side is 21. Now please, like for God's sake, don't use Heron's formula because the sides are known. Just use half base height. So area is half base height, which is half into 21 into 6, which is 63. And ABC is nothing but root 52 into root 325 into 21, which you can multiply. Just do the ABC by 4 into area and you'll get the radius. This is actually from one of the, like, I think a couple of years back it came in an IIM Calcutta. But just based on the identification that this triangle and this circle would be a circumcircle of this triangle. That's it. You basically knew 3 points on the circle, joined them, found the circumradius over. And then the next is just basic Pythagoras, right? It's just applying to figure out the sides. ABCD is a cyclic quadrilateral. Sides DA, CB are extended to meet at P outside the circle. Tangent drawn at point A meet BP at T. Sides again, like keep on drawing the diagram as you see read the question, right? So that details don't get missed. So there is a circle, okay. There should be a cyclic quadrilateral and we have to extend sides also. Tangent drawn at point A. So for example, if this is point A, this will be a tangent meets BP. What is P? So okay, DA and CB have been extended. So this should be D. This is A. So basically this is extended till infinity. And CB. Also, just from a conceptual standpoint, right? Whenever, like, if there's a line segment AB, if it says that AB is extended, then it will be extended from A to B and here this side. If DA is extended, then it will be extended here. So that's why, like, DA is extended means extending this side and not reverse. Then CB are extended to meet. Okay, let's draw CB also. Okay, let's just. So this would be C, this would be B. Let's just complete the cyclic quadrilateral. What are we given? This would be P. This would be tangent drawn at point A meets BP at T. So this tangent meets BP at T. So this is T and this is A actually. I should write it here. AT equal to 4. BT equal to 2. PC is 20. So this entire length is 20. Okay. PD is 28. This entire length is 28. AB equal to 8. So okay, this 8 I know. Find perimeter of ABCD. Okay. So I'm required to find the perimeter of this cyclic quadrilateral, but I know only one side. Now I need to figure out all the 3 other sides, but what is easy to identify is that it will be some application of tangent and secant, because you have both, you have this tangent, you have these seconds, so some application of that hopefully should work, right? So for example, like if you, the moment you see a tangent here, this one from point A which is given in the question, and seconds here, so you know that from this point T, if you see, This is a tangent, these are seconds. So I can use the tangent second rule to basically say that TA square will be equal to TB into TC. Right? So 80 I know 4, so this is 16, and let's just write it for reference, and this is a tangent second rule. 80 is 4, so this would be 16. Do I know anything else? Uh, this is TB. TB I know is 2 into TC. So TC would be 8. Right. Now TC equal to 8, this length basically. So if I know TC and I know that this is 2, so what will be BC? It will be 6. So one side I was able to figure out just simply using the tangent second rule, which was very evident from the figure based on point T. Okay, so this is figured out. Now there are two other sides remaining. Obviously this looks to me like a different side, right? Like, because there is no, it doesn't seem like this would be a part of any tangent second laws here, right? So this looks different, so we'll come to this at the end. Let's try to figure out what AD is. AD is part of a second, so something should work here in terms of the second rules, right? So using the second rules, basically we can write that PA into PD will be equal to PB into PC. Some things are given, PC and PD are given 28, 28. So basically PA and PA we can write as, because we need to find out AD, right? We need this whole is purpose is to find AD. So let's write in terms of AD itself. So it is nothing but PA is nothing but PD minus AD, and PD is 28. So basically this is 28 minus AD into 28 is equal to PB. What is PB? PB is PC minus BC. So PC I am given as 20, BC is 6, so PB will be 14. This I have now into PC. PC is again the original 20 only. So that's great, right? Because now I have, in this equation I have everything except AD, so I can find AD from this. So basically, okay, let's try to think of a smarter way to do it. Probably will be 14 into 20 by 28, so this is 10. So AD will be 18. So AD also now I have using second law. Let's just write it also. And again, clearly visible, right? Intersecting seconds. So AD should be able to be, sort of derivable based on that. So this is 18. This also I know now. Only side remaining to be known is CD, which is not a part of any second directly or any tangent. So it doesn't seem that we can find it out using those particular rules, right? So what can I do essentially here? One thing that we can do, right? And let's just explore some of the options, right? So one thing we can do that, okay, I know that this side is a portion of this triangle, right? So, and I know all the other side of this. I know this side, I know PC, which is 20 given. I know PD 28. I can find out this angle. Why can I find out this angle? Or the cos of this angle I can find out. Why? Because in this triangle, let's say I know all the sides. Or even in this triangle, I know PA, I know PB, I know this 8. I can figure out the cos theta of this and use the cosine law in this triangle then to find CD. Let me just repeat. In this triangle, 8PB, I know PA, which was 28 minus AD. PA was 28, like PD minus AD. So PD is 28, AD is 18, so PA is 10. I know PA is 10. Right. AB I know is 8 given. PB I know is 14. We just saw that this is 20 and this is 6, so this would be 14. So I know all the three sides of this triangle in ABP. I can find the cos of this using cosine law, then use that cos in this big triangle. I know two sides of it as 20 and 28. I can find a third side. That is one approach to do it. Correct. And that should give us the correct answer, absolutely. Is there another way to do it without, like, because cosine also is like in squares and stuff, right? So you'll at some point you'll start getting quadratics and stuff. But it'll definitely give you a correct answer, and it should be like it can be doable also in like a minute or something. But is there a faster way to do it as well? Let's use the fact that we haven't used till now in this question is that it's a cyclic quadrilateral. Like we have sort of indirectly used that while making the diagram, but not we have not used any property of a cyclic quadrilateral itself. What can I observe from the figure? So basically, if uh, let's say this is theta, for example, this angle is theta, this is 180 minus theta, this also is 180 minus theta. Why? Because opposite angles in a cyclic quadrilateral sum up to 180. So this angle and this angle are equal. Now that's a good discovery. Why? Because in this triangle and this big triangle, I know that this angle is common. So I only need to find one more equal angle, and I just found that. This angle was common. I needed to find one more equal angle to establish similarity, and I just found that because theta 180 minus theta 180 minus theta. Again, perfectly correct approach to go with the cosine law as well. It will give you the correct result. But identifying this, like using the property of a cyclic quadrilateral, would make your life a lot easier, because now it's just a direct side ratio game. I know now that the bigger triangle, let's say, or the smaller triangle, for example, ABP, will be similar to what? P should be common, so P is again the same. Again, the naming is pretty important as we've been saying since triangles. So P here and B here in this triangle. So B was equal to the D here. So this would be D, this would be C. So this is similar now. I need to find out CD. So I need to write these ratios of AB by CD equal to, let's say, BP by DP. This itself should give me hopefully. So it will be 8 by CD. Do I know BP? BP is 14. Yes, I know. Do I know DP? DP is given as 28. I know. So this is 1 by 2. So CD will be 16. So this is 16. Which means the perimeter is nothing but 8 plus 16 plus 6 plus 18. 48. So wonderful question really, like combining multiple concepts, combining tangent secant, secant secant, and also using similarity. So a very good question in terms of, you know, how to apply multiple concepts and also like how to like identify multiple concepts in the same problem. Because in questions of circles, you will like often find some properties of triangle. Like in the last question also we saw, right, that the ABC by 4 into area formula is basically what we studied in our previous session. But it is getting used here, right? Similarly, the radius formula that we had used at some places also is also from there. So this, in that way, this question was pretty useful because you now would be able to see that okay, how to identify these various concepts. Obviously, some of them like the tangent secant are easier to catch in such a diagram. So yeah, because you will see those intersections. But yeah, similarity is also one thing that could be utilized using the property that it's a cyclic one. So sine rule, the reason to avoid sine rule was because sine rule involves in two angles. Okay. Right. So you can use, but then you have to figure out two angles. It's a lengthier than even the cosine rule, because cosine you can just use one angle from the smaller triangle, use the same cosine in the larger triangle and get it. Yeah. So that is the only this thing. Okay. Cool. Okay. Now this comes something that we have sort of seen in the theory part very clearly. Find the number of common tangents to a circle given by this and this. So if this is, we can just directly write the center, and what will be the center? Half of this, negative the sign. So half of this would be -3 and negative the sign would be 3. This will be 2. What will be the radius? G square plus f square minus c. So G is 3 square, which is 9. F square is 2 square, which is 4. Minus c is -4. So this would be 3. So radius 1, center 1 is this one. And again, coefficients are 1 each. It's good to just check that before moving on. So C2 is again, this would be then -1, half of that negative would be 5. Radius 2 would be this square plus 5 square, 25, minus c, which is 22, which is root 16. So no, this is root 4. So this is 2. So this would be 3, this would be 2. So R1 plus R2 would be equal to 3 plus 2, which is 5. What is the distance between the centers? So distance between the centers is by distance formula x1 minus x2 whole square plus y1 minus y2 whole square. Pretty sure you would be very well aware of that. So it will be 3 and minus 1 would give you 4 square plus 2 and 5 would give you 3 square. Root 4 square plus 3 square is 5. Right. So basically the D is equal to R1 plus R2. So what is the setup that we're talking about then? Something like this. The distance between the center is equal to the sum of the radii. How many common tangents? 1, 2, 3. Done. So 3 is the answer. Okay, so yeah, this, like again, not more again of an algebra question than a geometry question itself, but yeah, this property came to use, that how to identify the number of common tangents or how to identify the setup of these circles based on equations.
Sir?
Yeah.
How do you calculate D?
Yeah, D is okay. So a distance between x1, y1 and x2, y2. There's a distance formula that gets used. So that is what we know the coordinates for. So just to be very clear on this, so this is 3 minus minus 1 the whole square, and this is 2 minus 5 the whole square. So let me just illustrate that here as well. This and this. Cool. So that's if now, for example, if in the same example, if you had gotten, let's say here you got D is equal to R1 plus R2, so pretty straightforward, right? If you would have gotten, let's say D greater than R1 plus R2, then it would have been a scenario like this, and you would have said, okay, 4 common tangents there. If you would have gotten a scene equal to D equal to R1 minus R2 instead of R1 plus R2, then it would have been a scene like this. So there's only one common tangent. If D was less than even this, like less than R1 minus R2, then there will be 0 common tangents, because that would mean the circle is inside the parent circle. And if it is in between these two limits, R1 minus R2 and R1 plus R2, if it is in between these two, then it would have been a setup like this. So 2 common tangents. So again, once you figure out D and R1 and R2, basically anything can be worked out in terms of common tangents. So pretty quick if you know this. So yeah.